Hello my dear students, today we will speak about the comparison between the galvanic cell and the electrolytic cell. What is the operations and processes that happen in the galvanic cell, and what is the processes or the reactions that happen inside the electrolytic cell. Then we'll speak with each other about some applications and some problems to the galvanic cell and to the electrolytic cell. First, the galvanic cell. What is the galvanic cell? It is a kind of electric cell that produces electric energy through a spontaneous oxidation reduction reaction. What happened here? Here, an oxidation of the anode, and the active metal leaves electrons here in this electrode. So this electrode is a negative electrode, and it is called anode, where the oxidation process happens. Electrons come here to the outer wire, which can be detected by an electric lamp, then go to the cathode. Electrons go to the cathode to attract the cations or the positive ions, which will accept electrons comes from the oxidation process which happens at the anode. There is a porous septum. So the two electrodes are of different kinds. Two electrodes of different kinds, maybe zinc, magnesium, maybe copper, maybe silver. The zinc or magnesium, the more active electrode, and copper or silver, the less active electrode. So the more active electrode is corroded, and is the more active electrode, which is the negative electrode, and act as anode. And the less active electrode act as cathode. It is the positive electrode. So the galvanic cell consists of two different electrodes, two different electrolytes, electrolyte of electrode Y and electrolyte of X metal. They are different electrolytes, and different electrodes produces electric current, converts the chemical energy into electric energy. So the oxidation reduction reaction that happen in the galvanic cell is spontaneous, so its value is positive. The electromotive force of galvanic cell is positive, and it refers to the reaction that the reaction is spontaneous. The oxidation reduction reaction is spontaneous. So here we'll speak about the electrolytic cell. The electrolytic cell, there is an outer source of electric energy as it converts electric energy into chemical energy through a non-spontaneous oxidation reduction reaction. So there is an electrode connected to the negative pole of the battery, and it is the cathode, to act as cathode, and another electrode which is connected to the positive pole of the battery, and it is called anode, dipped together in one solution of electrolyte. So here the two electrodes may be of the same element or of different elements. The electrolyte here is one electrolyte, and there is a non-spontaneous oxidation reduction reaction which is induced by passing the electric current through the electrolyte. So electrons go through the outer wire to the cathode to reduce the cations which is attracted to the cathode, and electrons go from the anode as an oxidation process happen to the anions. So the electrolytic cell, one electrolyte, it may be the electrodes is the same or different electrodes. The outer electric energy is used to induce or to produce chemical energy. So as it is non-spontaneous reaction that happen here in the electrolytic cell, so the electromotive force value is negative. Negative here refers to that the oxidation reduction reaction here is non-spontaneous. So this is the comparison between the electrolytic cell and the galvanic cell. So there is some problems here. Here the following diagram illustrates two electrochemical cells connected together in series. So the first electrode is zinc the second is copper, the third is copper, and the fourth is nickel. If we want to arrange these elements according to their activity, so the higher in activity is zinc, and after that comes nickel, and after that copper. Copper is the least active element here, zinc is the more active, and the moderate in activity is nickel. So if the first cell refers to here to that zinc is oxidized as it leaves electrons to the outer wire. Oxidized means act as anode. So here in this cell, between copper here and zinc here act as anode, and it is the more active electrode. It is oxidized to the solution and leaves the electron, comes out in the outer wire, so it acts here as an anode. So the oxidation reduction happens here, reaction is a spontaneous. There is a salt bridge, and this is a galvanic cell. Galvanic cell means the more active electrode is anode, which is a negative electrode because of the accumulation of electrons which comes out or arises from the oxidation that happened to the more active element. Here this is the cathode, which accepts the electron from another source to make reduction happen to the cations here, and it is positive as it attracts cations. Galvanic cell, anode is negative and cathode is positive. So this is anode and this is cathode. Look here at the other electric cell. The comparison here is between copper and nickel. It is supposed that nickel is oxidized because it is more active than copper. More active than copper, then it's supposed to be oxidized to nickel positive 2 and leaves the electron here, and the electric current go out. So if this happen, if this process happen like this, then nickel will act as an anode, and it is the more active element here. Nickel is more active than copper, but the actual process that happen here is that nickel accepts electron from another source, so it acts as cathode here, as it is the more active. It is supposed to be oxidized and leave electron to go out in the outer wire, but as it is an electrolytic cell, so it accepts electron from an outer source, so it acts as the cathode and the negative electrode in this electrolytic cell. The cathode, it is more active, but the oxidation reduction here between nickel and copper is a non-spontaneous oxidation reduction reaction. It is supposed that nickel is oxidized and the electrons go out of it. Here nickel is reduced, although it is more active than copper, so the reaction here is non-spontaneous. So nickel here is connected to the source which gives the electron, to the battery which gives the electron. The other galvanic cell acts as battery for the second galvanic cell. So nickel here is connected to the negative pole of the battery to act as cathode and negative electrode in the same time. Copper here is connected to the positive pole of the battery to act as anode, and it is the positive pole. So let's see about the examples or the problem or the question. Which of the following determines the occurring energy conversions in cell 1 and 2? Cell 1 is a galvanic cell, so it converts chemical energy into electric energy, correct? So the choices which refers to the electric energy converted to the chemical energy is wrong. So the first cell transfers chemical energy into electric energy. The second cell is the opposite. It converts the electrical energy into chemical energy, and the correct one here is C. The first cell is a galvanic cell, converts chemical energy into electrical energy, and the second cell, non-spontaneous oxidation reduction reaction, converts electrical energy from an outer source to chemical energy. Let's speak about another example, talk about another example. Here, in the opposite diagram, what is the type of this cell? What is the name of the device X? Look at this cell. This cell composed of iron, which is more active electrode, and silver, which is less active electrode. Iron is higher than hydrogen. It has an oxidation potential with positive value, and silver from the coinage metal. So it is less active than hydrogen and has a very high reduction potential. So iron is easily to be oxidized and silver easy to be reduced. So iron leaves 2 electrons and oxidized into the solution, and leaves electron to go out of the cell in the electric wire and go to the silver metal to reduce silver ions in the electrolyte into silver element. Here it is correct. This acts as anode and it is more active element, and this acts as cathode and it is less active element. The anode here is corroded, and the mass of the cathode increases. So the reaction here is spontaneous. So it is a galvanic cell, not an electrolytic cell. So here electrolytic cell is wrong, electrolytic cell is wrong. So if this is a spontaneous reaction, there is no electric source from outer. There is no outer source of electricity. So it is not a battery. It is not a battery. So those are wrong. It is a galvanic cell, and this device is a voltmeter. Let's speak about another example. The following figure shows an electrical circuit composed of 2 electrochemical cells. This is the first cell, electric cell, and this is the second cell. By the way, the second cell composed of 2 similar electrodes, graphite and graphite. So without speaking, it is an electric cell. Here we have more active element magnesium and less active element silver, and there is a salt bridge. Okay, so graphite and graphite, same electrolyte, it will not produce any electric current, but here there is more active element magnesium, less active element silver, and salt bridge. So it is a galvanic cell, produces electric current by the oxidation of magnesium metal into magnesium ion and leaving electrons. So the electric current goes from magnesium to this graphite electrode. So this graphite electrode acts as cathode, as it is connected to the negative pole of the electric source, which gives the electrons. The other is positive pole. Okay, here it is a galvanic cell composed of more active, which is magnesium, and less active element, which is silver. So silver accepts electron here, and which comes from the oxidation of magnesium, and this electrode uses this electrons to reduce silver ions from silver nitrate solution to be precipitated or deposited as silver atoms. So this is a galvanic cell, anode, which is the negative electrode, and cathode here, which is the positive electrode. So let's see the options here, or the choices. Which of the following indicates 1, 2, 3, and 4? 1 is the cathode or the anode. 1 is the cathode, it is a galvanic cell, and silver is the less active element. So 1 is the cathode. So 1 is not the anode. The second, it is the anode of the galvanic cell, magnesium, which is more active. Yes, those are wrong. It is not cathode. Here it is an electrolytic cell, as the same electrolyte, the same element, graphite and graphite. So there is no electric current produces from this cell. So we have to introduce electric current from outer source to make a non-spontaneous oxidation reduction reaction. So the electrode which is connected to the negative pole of the source, it acts as cathode, and it is the negative electrode. So it is not positive electrode, it is a negative electrode. So here we have the correct one, which is B. At this point we finish our session, so thank you all. Keep with us, stay with us. We'll explain everything, and we'll reply about all questions. We'll reply all questions. Thanks.